introduction. Thank you.
Okay, thank you. Hello everyone. I'm happy to be here again to present my work on modeling dialectal variation for Swiss German ASR. Okay, Switzerland has four national languages: German, Italian, French, and Romanish. So the majority of the people speak in German, but that's not the German spoken in Germany. So Swiss German is a dialectal spoken language. So when a Swiss wants to talk to a German, he needs to switch to standard German, and that's not what is convenient for him or her. So there need to be an interpreter to do that. Swiss German is not a coded language, so writing in Swiss German was just recently been introduced because of the text messaging. There is standard Swiss German, which is a written form on official documents in books, newspapers. And this standard Swiss German is also different from standard German in Germany. So it's more about the attitude toward the countries, and it's based on how they want to identify themselves and discriminate them from the German people. So the differences in standard German with Swiss German is on different levels of linguistics, including pronunciations, which mostly introduced by the dialectal speakers, and it's on the stress, consonant, vowels, and prosody, and also on orthography, because of the most of the words coming from French, Italian, and they kept their original form, but some spelling reforms. And also due to the introduction of the typewriting and the fact that they had to type in German, French, and Italian, there are limited keys on that typewriting, so that causes some malformation of the words. And also there's differences in syntax and also definitely on vocabulary. Swiss German is a well-studied dialect, and as you can see on this map, it's the results of a cluster analysis on different linguistic, on vocabulary, phonology, on morphology, and on syntax. So what is the problem is we want to build a speech recognition for Swiss German. We face a number of challenges. First of all, it's a dialectal speech. There is no standard orthography for writing, and also the inconsistency in writing. So different people may write a word differently. And we have very few publicly available data sets, and most of them are out of domain and very limited in a specific domain. And we also have an issue with the auto-vocabulary and code switching. So the task is to do ASR for Swisscom TV box. It's very simple commands that people say to the TV in different languages, but we want to work on Swiss German. So these kinds of commands, as you can see here, like what will the weather be tomorrow in Bern, something like that. In order to have to collect the data, we try to simulate a realistic scenario. So we used 8 different microphones in different places, placed them in different part of the room. 2 of them are a closed talk, so there's a remote control, so people can speak to, and that's the channel we use for our ASR. And also people speak on different locations and utter different voice commands, either by reading from notes or free talk. And transcriptions of these audio were generated manually by some linguistics. So this is the project for collecting the data. We have different dialects in different regions, and this is the expected number of recording and the final number of recordings, as you can see here. And we also have collected data for English, French, Italian, and Standard German. And we also try to collect data from different age ranges, as you can see here. Okay, the corpus that we collected is about 440 hours of data, and from 3,800 speakers. And it covers most of the major dialects in Switzerland, including Bern, Valais, Zurich, Eastern Swiss, Grimson area, and Central and Northwest Swiss. We split the data into training and validation, and we also have a data set for tests from all these dialects. Okay, for Lexicon, Swisscom also provides a lexicon for spoken and writing Swiss German. It's freely available, and it maps standard German words to their pronunciation in Swiss German and also their writing form. And there is a total of 11,000 standard German words that are mapped to the pronunciation. Most of them are from these regions. We have a manual annotation for about 9,000 by native linguists without referring to the pronunciation. So they just try to collect this information from people. And but a subset of 600 words were collected using books and dictionaries. So they are not very well, collected because they are from non-native speakers. So we also use a G2P model to map them to the writing form for those 600 words. And these are some examples of the standard German words mapping to This is standard words that are mapped to different dialects. You can see that we have the writing forms here. Most of them for this word are almost the same, but we also have some words like lecker that is totally different in some regions. Okay, dialect variation. We have, even the expert linguist could provide different writing for words, so it's not consistent. Training a language model on Swiss German text will result in inconsistency and high perplexity. So in this case, normalization is required. So we map all the variants of a word into a single word form. So in this word form is first we check the standard German form, and if they are the same in morphology and etymology, then we pick that as a normalized form. Otherwise, we use the most common or the one that is more acceptable majority of Swiss people. So based on this lexicon that maps German a normalized form to their variants, we built a lexicon and then train a grapheme to spelling. As you can see here, this is some samples of the normalized form and their corresponding writing variations in different regions. So for training, we align the normalized form with their corresponding variations, and based on that, we train a unigrammar language model, and then finally we have a weighted to finite state transducer model that we use Phonetosaurus software in order to model that. So during decoding, we pass through this graph, and in order to generate the n-best path to generate for each word the n-best writing form. So here is an example of the output of this modeling. So for instance, the word program in German. In here we have 3 manually generated writing forms. And then this is the automatic ones that we generated by this model. And we also have this word meaning living room. We don't have any word in our manual lexicon, but our generated model provides a couple of them, which actually some of them are valid, but yeah, if it's not valid, it's not a problem, because we actually use a decoder in order to find the best path. So normalization is context dependent, and in Swiss German a word could be mapped to multiple normalized forms. So in that case, a language model could reduce the ambiguity and improve the word rate. So we train our language model on normalized text, and we use a 5-gram language model in this case, using the transcription of the speech and also some augmented text that we collected by generating them using templates in the commands to the TV box. So for our experiments, we used the acoustic model based on a pre-trained cross-lingual speech representation model, which is trained on unsupervised multilingual data, 56,000 hours of data. And then we fine-tune it to our Swiss German dataset. And this is we use CTC loss function and use character sequence. So the decoding is both a lexicon-free and a lexicon-based approach. In the lexicon-free, we don't have the problem without the vocabulary, but in the lexicon-based, we try to limit the vocabulary to a specific lexicon. And then we pass through our acoustic model and then language model to generate the score. Okay, here are the results. The first line, as you can see, the lexicon free is actually without using any language model, and it's the output, the best path through the output. So the word rate, as you can see, is about 17.5, and the corresponding dialects in different regions. By using a lexicon that maps every word to itself, actually, it's just to limit the vocabulary to a specific vocabulary list, so as to avoid most of the writing problems. Then we could improve the results here for all of these dialects, as you can see. This manual system is actually the one that we used all the variants of the words using so manually generated lexicon, and the automatic one is the one that we generate by this approach. And the interesting thing about this is about in this Grinson area, GR, where as you can see, using even a manual lexicon did not improve a lot, and the fact that there are few amount of data in our lexicon and our speech data, but with this automatic approach we could improve it further to 18.1. And the fact that this number of some of these dialects are low resource, and we have the majority for Zurich area and for the Bern area. Okay, in conclusion, we described our speech recognition system for Swiss German. We generate multiple word candidates for different dialects in Swiss German, even for words, unseen words. The ASR system could normalize word variants when performing a beam search decoding, and the pre-trained cross-lingual representation was in fact very effective and provides very good performance compared to our previous systems. And lexicon-based approach has some limits on out of vocabulary, but it could improve our system by doing the normalization. Thank you so much.
Okay, we have a few minutes for questions. Are we having questions in the audience? I might start with the question. So actually, so your baseline vocabulary, how big is that, and how many additional entries did you get actually through this approach?
Okay, I mean the vocabulary size that we are using. Because it's a limited domain, it's on TV, we have problem without the vocabulary because of the name of the movies, streets, and different things. But the vocabulary that we are using is around 80,000 words and not more. And that, I think, was enough for our TV at this time.
And how many different, so are you adding new words or actually on pronunciations to the existing words?
It's easy to add words to the lexicon because the decoder is independent. And yeah, it's if we have new vocabularies from like the movie names, we add them to the lexicon. Yeah.
And so how many additional words compared to the standard German version did you add?
Okay, the German, because the vocabulary size is huge and we cannot add all the vocabularies. It's like more than 2 million words. So.
Okay, so you subsample for the recognition, or?
Because in our TV domain, we have some templates for whatever a user can utter to this box. So we have limited vocabulary there.
Okay.
Yeah. We can collect them. Yeah.
Well.
Yeah, thank you for this interesting presentation. Oops, sorry. Could you say something about how you evaluate? Because you have the different dialects and they have completely different written forms. Do you also normalize when you evaluate, or do you really take the dialectal script as it should be for the different dialects?
Okay, we normalize them during decoding, because in the lexicon we have every word and the mapping to this normalized form.
So it's effectively like pronunciation variants then?
Yes, the kind of writing variants for each show, because sometimes yeah, the way they pronounce it is the way they write it. So it's very similar to the phonetic.
And I mean, I think you can interpret it like pronunciation variants, like right? So did you use pronunciation probabilities or dialect probabilities?
No, in that case, we just used kind of modeling by using this graph. So how to go through the normalized form and to generate the sequence, the best path, the best probabilities of the writing form. So it's kind of probability based, but yeah, not in this way.
Okay, thank you.
Yeah, you're welcome.
So okay, maybe the last question, is there any? If please.
Yeah.
Thank you for the presentation. I was wondering about the number of the number of engram that you selected for your experiment was 5.
Yeah.
So did you check the others? Because I think 5 can make, I mean, it's kind of create a bias for the words, especially if it was formed. So did you check the other engram, the other numbers, like for the word error rates? And why did you decided to go for 5?
Okay, we tested a couple of them. So because we have very limited vocabulary, we could increase that like to 6 or more. However, we didn't find any improvement. Yeah.
Okay, thank you to the speaker again.